Hello friends, we are back. Now in today's video I'm going to explain you how to solve LPP using a graphical method. Before moving to the method, let's see the working rule. First we have to formulate the LPP if it is given in theoretical form. We have to draw x and y or x1 on y1 axis. The non-negative constants x1 greater equal 0 and y1 greater equal 0 implies that the value of the variable x and y lies in the first quadrant only. Third, we have to plot each constraint on the graph. For this, consider constraints into equality form. This is the most important form. Identify the feasible region or optimal or solution space that satisfies all the constraints simultaneously. This is the most important one. For greater equal type constraints, the area on or above the constraint line, that is away from the origin, will be considered. If your constraint is of the greater equal type, you have to shade the region away from the origin. For less equals type constraint, you have the area on or below the constraint line, that is towards the origin, will be considered. The most important thing here is to see that your constraint is greater equal type and you have to shade the region away from the origin. And if it is of the less equal type, you have to shade the region towards the origin. The area common to all the constraint is called feasible region or convex polygon, which we shall show by the shaded region. This set is called convex set. Let's move on to our example. We have to solve the following linear programming problem by graphical method. Maximize z 3x1 plus 4x2 subject to x1 plus x2 less equals 450, 2x1 plus x2 is less equals 600, x1, x2 greater equals 0. Before solving the example, let's construct a table. For this inequalities, equations, point on x1 axis, point on x2 axis and direction. My first inequality is x1 plus x2 is less equals 450. I will convert this inequality into equation. So this will become x1 plus x2 is equals to 450. Point on x1 axis means your x2 is 0. So if I put x2 in this equation as 0, I will get 450 and 0. Point on x2 axis, that means x1 is 0. So if I put x1 0 in this equation, I will get 0, 450. Now my constraint is less equals type. If it is less equals type, we have to shade the region towards origin. Going to my second equation says 2x1 plus x2 is less equals 600. 2x1 plus x2 is less equals 600. I'll convert this into equation. So this is 2x1 plus x2 is equals to 600. Point on x1 axis, that means I have to put x2 0. So if I put x2 0 here, I will get 300 0. If I put, now I have to find point on x2 axis. So that time I'll put x1 0. So this is 0, 600. Constraint is of the type less equals. So I have to shade towards origin. Here I have formulated the table. I will draw x1 and x2 axis. So my axes are ready. This is my x1 axis. This is my x2 axis. I'll plot this point. This is 450, 0. That means 450 on x-axis, y-axis 0. So I'll get 450 somewhere here. My second point is 0, 450. So this point will be somewhere here. 0, 450. I'll join these two lines, these 2 points, and I'll get a line over here. Now it says that I have to shade towards origin. So I just mark arrows saying that this will be my region. My second point is 300 and 0. So this is 300, 0. And my next point is 0, 600. 0 and 600. I'll join these 2 points. Again it says towards the origin. If you could see, this is my common region. This is my common region. So this is my A point, this is my O point, that is 0, 0, A point is 300, 0, this is my B point, this is my C point, this is 0 and 400. B point is the intersection point of 2 lines. So I'll have to find the common point, that is x1 plus x2 is equals to 450, 2x1 plus x2 is equals to 600. I'll subtract. So I'll get minus x1 is equals to minus 150. Therefore, x1 is equals to 150. I'll put x1 is equals to 150 in this equation. So I'll get x1 plus x2 is equals to 450. That is x2 is equals to 450 minus 150. That is x2 is equals to 300. So my this point is 150 and 300. Now I have got 4 points, that is O00, A300, B150, 300, and C is 0 and 450. Let's make another table. Here I have to make 2 columns. First is point, second is Z. Here my Z is 3x1 plus 4x2. So Z is equals to 3x1 plus 4x2. My points are O00, A300, B150 and 300, and my C point is 0 and 450. I'll put the values of x1 and x2 in this. I'll get this is 0, this as 900, this as 1650, and this as 1800. My example is I have to find maximum of Z. So here I get 1800 as maximum value. So this is my max. Therefore, we observe that the maximum value of Z is equals to 1800 at point C, that is 0 and 450. The solution of the given problem is x1 is equals to 0, x2 is equals to 450, and Z max is equals to 1800. So here in this video I have explained how to find the value of linear programming problem by graphical method. In the next video we shall see simplex method. Till then, thank you.